Welcome back, everybody. Today, we are looking at what happens to the market when the government imposes what is known as an excise tax. So we'll look at what excise taxes are. We'll determine how to measure the total tax revenue collected by the government. We'll look at the impact that these excise taxes have on market efficiency, and particularly in the creation of deadweight loss. And we'll look at how elasticity of demand impacts the amount of deadweight loss in the market. So we start with the idea of what is, in fact, an excise tax. An excise tax is a per unit tax assessed by the government on products. So some examples in the real world include the gas tax. For every gallon of gasoline you purchase, there is um, a federal tax that is placed on that gallon of gas that you pay. And so you pay that tax for every gallon you purchase. Cigarette tax, same thing. There is a per packet or per pack tax on every pack of cigarettes that's purchased in America. And there are lots of reasons why excise taxes are implemented, but it's important to recognize that the decision to implement an excise tax will create a certain amount of market inefficiency. It will disrupt the ability of the market to reach the allocatively efficient outcome. So excise taxes are paid by both consumers and suppliers. It turns out that it doesn't matter who the tax is imposed on, whether it's consumers that have to pay the tax or suppliers, both sides will have to pay a portion of the tax. Consumers will pay in the form of a higher price, and suppliers will pay in the form of a lower price received. Now, who has the higher tax incidence, who has to pay the highest portion of the tax, depends upon the elasticity of supply relative to the elasticity of demand. And we're going to take a look at that in just a second. When it comes to graphing an excise tax, it does not matter really who the tax is imposed on. We're going to reach the same conclusion. It's still going to look the same. And so if I put the tax on consumers, let's assume there's a $1 per gallon tax that's being placed on consumers for gasoline, then what will happen is the demand curve will shift to the left. It basically shifts down so that consumers are willing to pay $1 less per gallon of gasoline because then they have to pay $1 to the government, and so their total amount will stay the same, but the price that they are being charged by the gas company will have to come down. And so we could shift that demand curve down, and you'll notice that when we do that, there's a wedge that forms between the original supply curve and the new demand curve, and that wedge is the size of the tax. It's a $1 tax in this example, and you'll see there's a $1 difference between the original demand curve and the new demand curve. Now we could also put the tax on suppliers. We could assume there's a $1 per gallon tax for every gallon of gasoline sold, in which case the supply curve would move up by the size of the tax. Suppliers would need to receive $1 more for every gallon of gas that they sell than before because they're going to receive $1 more, and then they're going to turn around and give that dollar back to the government, and that way they continue to receive the same amount of money per gallon. And so if we shift the supply curve up by $1, then we find ourselves in the same position we were previously when the tax was put on consumers. In both cases, the new price will be $2.95, and the new price received for suppliers will be $1.95. Again, you'll notice that the price did not go up by the full dollar because the consumers are paying some of the tax and the suppliers are paying some of the tax. So it doesn't really matter who gets the tax levied against them as long as you draw a tax wedge between the original supply and demand curve that has a vertical distance equal to the size of the tax. You are going to be able to solve this problem the same way regardless of who has to pay. So what we'll see then is that $1 tax wedge brought the new price to $2.95. So the consumer incidence is 95 cents of the tax. They are paying 95 cents more than they did before when we were at the original equilibrium point. And the suppliers are paying 5 cents in tax incidence in terms of 5 cents less per gallon than they received. They used to get $2 and now they get $1.95. In this case, you'll notice that the consumer incidence is higher than the supplier incidence. And by looking at their curves, we can see that the demand curve is relatively more inelastic than supply. That is, consumers, while they don't like higher prices and will purchase less gasoline, they will not purchase nearly as little as the suppliers will get out of the market if they lose from the original price. That is, consumers don't like the higher price, but they're not as moved by it as the suppliers, who are very elastic. Change the price on them, and the quantity they provide changes drastically. If the elasticities change, if the relative elasticities change, then we can see how the tax incidence changes. In this case, we're going to assume a $5 per parking space tax. Again, it doesn't matter who the tax is on. We just know that as long as the price is $5 for the tax, then we're going to find a tax wedge, a vertical distance between supply and demand, equal to $5. So here, supply is relatively inelastic and demand is more elastic. If we find that $5 tax wedge, we find now that the new market price is $6.50 paid for by consumers, and that the new price received for suppliers is $1.50. So there's a $5 tax wedge, $5 difference between the supply and demand curve. That's the tax wedge. And so we can see that consumers are paying more. They have a tax incidence of 50 cents. They're paying a higher price than before. And suppliers have a tax incidence of $4.50 because they are receiving a lower price per gallon than they got before the tax was levied. The rule then for who pays the higher tax incidence in the case of an excise tax is that whichever side, consumers or suppliers, whichever side is more inelastic will have the higher tax incidence than the other. Both sides will be paying a portion of the tax, but the person or the side that pays the greater portion will be the one that is most inelastic. Now, why does the government choose to impose these taxes even though it's creating a certain amount of inefficiency? Well, on the plus side, it's creating revenue for the government. Government needs money to function. They need to pay for things like parks, roads, fire, police. And so they can impose an excise tax to raise money. And oftentimes, these taxes are imposed on things that are considered negative. So we sometimes refer to them as sin taxes. So the government can tax alcohol or they can tax cigarettes because we'd rather people not use those products. And those people who use those products tend to be very, very inelastic. So it doesn't matter what the tax is, they're going to buy the product and pay the money. So it's an easy form of revenue for the government. Now, how much money do they collect? Well, we've calculated the tax wedge. That's that vertical distance between supply and demand. That's equal to the size of the tax. And then I can multiply that amount by the number of goods being sold. So the quantity that corresponds with that tax wedge tells me how many units I'm selling. So in this case, it's a $40 tax times 5,000 hotel rooms. And this area in green, this rectangular area, is all of the money being collected by the government for the tax. This upper half is being collected by consumers or from consumers, and this bottom half is being collected from suppliers. Now, the downside to all this is it does create deadweight loss. There are lost transactions. There is a loss of consumer and producer surplus that goes with it. But those costs can be outweighed by the benefit of revenue for the government. So before the tax, we were at the allocatively efficient point where the supply and demand curves intersect with each other. And we had consumer surplus, the area above the price but below demand. And we had the producer surplus, the area below the price and above supply. And that was together adds to total surplus. We get the most total surplus when we're in allocative efficiency. But that excise tax moves us away from allocative efficiency. That excise tax puts us in a place where some of that consumer surplus is now going to the government in the form of tax revenue. Some of that producer surplus is going away to the government in the form of tax revenue. And so it does leave some producer and consumer surplus, this white area above tax incidence and this white area below tax incidence. We still have producer and consumer surplus, but it's been reduced. Some of it got taken away in the form of taxes, and some of it got taken away in the form of deadweight loss. And so we do have that triangular area pointing from where we currently are, our current quantity, and then it's an arrow pointing to the allocatively efficient point where the supply and demand curves intersect. And so we can trace out that triangular area and then calculate the total amount of deadweight loss by using the area of a triangle, 1/2 base times height. So we could look at a graph like this and take a chance to practice this, and hopefully it makes sense. We're going to work through this problem. So like always, you'll press pause when you're ready to answer it, and then when you've got your answer, press play and see if you got it right. We want to make sure that we highlight areas of consumer surplus, producer surplus, deadweight loss, and tax revenue, so we know each of the different areas in this graph, as well as be able to calculate the deadweight loss and the tax revenue, assuming that we have a tax equal to $2. So when you're ready, after trying to solve it, go ahead and press pause, and then when you're ready, press play, and we'll see how you did. As we said before, it doesn't matter who the tax is imposed on. We just need to find a tax wedge, a vertical distance between supply and demand equal to the size of the tax, in this case, $2. So, we can start at 9, for example. We can say, well, 450 and 550, that's only $1. So that's not enough. So let's look at 8, a quantity of 8 million rides. Here, the supply price is $4. The demand price is 6. That's a $2 difference. So that's our tax wedge. So that tells me that there are going to be 8 million rides that are being given. Each is charged $2 per ride. So 8 million rides times $2 tax equals a $16 million tax revenue. And so that's what this rectangular area would come out to. Now keep in mind that the axis here is sort of broken. It stops at 5. It really should go to 0. When it comes to what's left of consumer surplus, then the price that consumers pay is $6. They were paying 5, now they're paying 6. So this area in yellow is the area of surplus. People were willing to pay more than 6, but they get to pay 6, so there's some extra, but only so far as it gets to 8 million rides. Same thing with producer surplus. Suppliers were willing to receive less than the price they get to keep. In this case, they're getting to keep $4. They were willing to accept less, so there's still some producer surplus, but not as much as there was before. And because we're at 8 million rides and not 10 million, we have deadweight loss. And it's an arrow pointing from where we are to the allocatively efficient point. So there's one portion of the arrow, and then we follow the demand curve and the supply curve that creates the rest of the arrow. So we have this triangular area. So we're going to calculate the area of that. It's 1/2 base times height. So 1/2 times the tax wedge of $2 times the number of lost sales, 2 million sales. So 1/2 times 2 times 2 equals $2 million in deadweight loss. When it comes to elasticity, the way to minimize your elasticity, if you're the government and you don't want to lose a lot of value for consumers and producers, the best thing you can do is choose a product in which both supply and demand are both inelastic. Your ability to raise the price without affecting the quantity demanded and quantity supplied by very much will help minimize deadweight loss. So we look at an example of this graph on the left, very inelastic supply and demand, and there's a tax wedge, and the area of deadweight loss is in yellow. If we have very elastic supply and demand, this vertical line is the same amount. It's the same vertical distance as the graph on the left, but you can see that the yellow area of deadweight loss is significantly larger when both supply and demand are elastic. That's why government does choose excise taxes on things that are relatively price inelastic, and that's the things, the sin taxes that we talked about, because it disrupts the market the least. Next time, we'll talk about utility maximization, and I will talk to you then.